Okay. So I heard that it was a bit too fast last time, so maybe this time I try to make it a little bit slowly. So today we're going to split this exercise into two parts. The first part will be very similar to our last laboratory. So we are going to use a similar trainer kit, but this one is for frequency modulation and demodulation. And we're going to observe the signals using oscilloscope. But we're going to do it only in the time domain. Then we're going to switch to frequency domain, and we're going to use such element, which is analog discovery module, and we're going to generate signal using this module. And I think it will be maybe a bit more interesting for you. Okay, so we have this trainer kit, which is already switched on. It's this cable connected to the power supply. And it contains several blocks as previously. So we have sine wave generator, modulator, we have a demodulator, low pass filter, we have microphone preamplifier, power supply, and audio amplifier. So first of all, we're going to check the power supply using this multimeter. Okay. And we're going to measure the voltage. So first we connect to the ground, and then to plus, it should be 5. It is almost 5, and then to minus, and it's minus 5 volts. Okay, so the trainer kit works correctly. And first of all, we're going to observe the sine wave generator signal. So we're going to connect the oscilloscope probe. So we're going to use 2 probes. One is, this time, the first one is marked with this pinky tape, and it will be our yellow signal on channel 1. And the other one is marked with this blue tape, and it's channel 2, which will be in blue. So first of all, we need to connect the ground. Okay. Yeah. And we can see already the sine wave signal. And using these 2 knobs, we can change the amplitude and the frequency. So as you see, now we change the amplitude, and now the frequency. So we're going to determine the minimum and maximum amplitude, and also the minimum and maximum frequency. So these values are shown here. So let's check first the minimum amplitude. and it shows 80 millivolts. And then in the opposite way, let's check the maximum amplitude, which is 2.2 volts. Okay, and also the minimum frequency. So the minimum frequency should be visible here on the bottom. So it's 560 hertz. Okay, and now the maximum. And the maximum frequency is 10.2 kilohertz. So let's set it to 2 volts amplitude and 3.4 kilohertz frequency. Yeah, it's almost 3.4. Okay. And now we're going to connect the the oscilloscope's second channel to the modulator output. Okay, so let's leave channel 1 with the sine wave, and then we take the other oscilloscope probe. We connect first the ground, and we're going to connect it to the modulator output. The sine wave generator is not yet connected to the modulator, so we're going to observe only the carrier signal. Okay. Let's turn on channel 2. And now we can observe the carrier signal, but we need to adjust the x-axis scale. Okay. And also we want to read the amplitude and the frequency. So we have the amplitude here. We need also the frequency. So we press here, measure. We choose channel 2. And we pick here frequency. Okay, now we have it. And we can read the value, which is 140 kilohertz. So this is the carrier generator frequency. (114). And the amplitude can be changed from 0 volts sorry, it's 0 up to I think the oscilloscope probe is set to times 10 now. Now it's set to times 1. Okay. Camera has to. Let's set the trigger to channel 2. And we don't need channel 1. Okay. So now we can see the carrier signal. So the maximum amplitude is 3 volts. And its frequency is 114. Okay. And now we're going to connect the sine wave generator to the modulator input. And we're going to observe the modulated signal. So here our sine wave is our modulating signal. Yeah. And we're going to watch sine wave on, on channel 1. Okay. And we need to switch to times 10 now. Okay. And now we can observe let's adjust the position of these two and also the x-axis scale. And now we can observe a modulating signal, which is our sine wave generator on channel 1, and modulated signal, which is in blue. So it's a frequency modulated signal. Okay. And now we're going to connect the modulator output to the demodulator input. And we're going to observe the signal of the demodulator at the demodulator output. So we have again sine wave on channel 1 and demodulated signal on channel 2. Okay. Maybe now it's better. Okay, and now we're going to connect the demodulator output to the input of the low pass filter. Okay. So this is our sorry. This is a signal from the low pass filter. And now the instruction list says that we need to set the sine wave to 4 kilohertz and 1 volts. So let's lower the amplitude to 1 volt. Now we have 4 kilohertz. Okay. And now we're going to connect the microphone. Okay, so we have this microphone. And we connect it to the microphone preamplifier. And we're going to connect the output of this preamplifier to the input of the modulator. Let's do it step by step. So we connect the microphone preamplifier to the input of the modulator. Then the modulator output to the demodulator input. And the demodulator output to the low pass filter input. And from the low pass filter, we go to audio amplifier. Okay, and we're going to observe a signal from the microphone preamplifier. So it's here. It will be our channel 1. And the signal from the audio amplifier, it will be our channel 2. And first, we need to adjust adjusts the scales. Yeah, now we can see channel 1. We should be seeing now also channel 2. We need to adjust the x-axis scale now. Okay, let's see. No. Okay, yeah. So now we can observe as I am talking, we can see signals at both channels. So the yellow signal is a microphone preamplifier and the blue signal is audio amplifier. Okay, so now we're going to go to the second part. Okay, so we're going to disconnect it. Not going to, we don't need the oscilloscope. So I show you how to connect this analog discovery module. And then I have to arrange the windows in the program. So I think we're going to need a short break then. So first of all, we have such module. And as you will see, it will serve as our oscilloscope, generator oscilloscope, and also spectrum analyzer. So we're going to use two inputs. So it will be, yeah, the colors are terrible in this camera, I think. So our so this will be our two inputs. So input 1 is in orange and input 2 is in blue. And we're going to have also ground, which is these two black cables, and also the output, which will be this blue cable, because we're going to generate a sine wave signal from this module. And because this is the differential input, we're going to connect, so it has plus. Here, as you see, it has the numbers are not really visible. So it has plus, and at the bottom it has minus. So the plus will be our input, and the minus we're going to connect to the ground. So I have such custom-made connection. It looks like that. So I'm going to connect this element to the ground, and I'm going to have 4 inputs of the ground. Okay, so we're going to connect it right here. And let's connect first the ground. So the minus from first input and the minus from second input. And these 2 black cables, which is the ground. Okay, and the other one. Right here. Okay. And I have also, as you can see, the capacitors at both ends of the input. So now I'm going to switch to this waveform software. So let's stop here and let's make like 3 minutes break, okay? And then we go back. Yeah, more or less. So I arranged this 3 more windows. I added them to our screen. So now we are able to see, so the first one on the top, on the right top is waveform. So it's our generator. We're going to set the parameters for the input signal. So we can adjust the frequency and the amplitude. So these are all from the waveform software. And on the bottom, you can see the oscilloscope, which is here. So it's on the right, and on the left, you can see the spectrum analyzer. So here, we're going to observe the FFT signal in the frequency domain. Okay. And we are also able to see our trainer kit. So now let's connect it. So as I said, we have 2 inputs here, and these inputs will serve as our oscilloscope probes the same way, and 1 output. So now we're going to connect this output to the input of the modulator. So I have such great connection, house-made connection. So we're going to put it here. And now we connect the, sorry. Our output signal, and also we want to see it on the oscilloscope. So we're going to connect also the first input. Yeah, right here. Okay. And now we're going to set the parameters. So let's set them similar to our sine wave signal from the beginning of the classes. So let's set the frequency to 3.4 kilohertz and amplitude to 2 volts. Okay. And now let's see. Here we press run. Yeah. And now we can observe the signal. So we have here channel 1 and channel 2, and we can adjust the offset and the range, which is the y-axis scale, and also we can adjust here the base, which is x-axis scale. So we can maybe, yeah, do it like that. So this is our input signal. And now we're going to observe we're going to observe the output signal, so the modulated signal. Sine wave is our modulating signal, and now we're going to observe using this second input. We connect it to the output of the modulator. And we need to adjust. Yeah. So maybe let's provide some offset. Okay. Let's put it here, and let's put the modulated signal. For example, here. So it's very similar to what we saw using oscilloscope. So now let's move to the spectrum analyzer. So we also press run here. And now we can observe these two signals in the frequency domain. So the yellow signal is the FFT from the of the sine wave. So it's the sine wave generator signal. And the blue waveform is the FFT from the modulated signal. Okay, and now now we can see what will change when we change the parameters of the input signal. So let's say, okay, I'm going to, now I'm going to make it quite fast, but after that, we're going to set few parameters, and we're going to take some screenshots for a few of the parameters. So when we lower the amplitude, yeah, you can see the change of the bandwidth of the spectrum is getting narrow. And when we increase the amplitude, it broadens. Yeah. And also when we change the frequency, so now we decrease the frequency and now we increase it. So when changing the frequency, we can see that the amounts of these harmonics is changing also. So let's set few parameters here. Let's set 1 kilohertz and 2 volts. So it's it looks like that. And now let's say 5 kilohertz. Looks like that. So now the amplitude is fixed. We change the frequency. And now when we further increase the frequency to 10 kilohertz, and also to 20 kilohertz. Okay, let's set it to 5. And now we change the amplitude. So we fix the frequency to 5 kilohertz. And we set the amplitude, let's say, to 500 millivolts. So it's actually the essence of the frequency modulation. So what happens when we change the parameters of the input signal? And what's the impact on the bandwidth of the modulated signal then? And now let's set it to 100 millivolts. And one more thing here, I'm not sure if you were able to notice it, because yeah, I'm aware it's quite fast. So yeah, I'm going to show you a few more parameters and then one more interesting thing. So now we can maybe, let's increase the amplitude to 3 volts. And to 5 volts. Okay, and now I'm going to change the amplitude, and you're going to look at the spectrum. So I'm going to decrease the amplitude, and maybe, yeah. Maybe some of you can notice that when we change the bandwidth, the amplitude, so also the bandwidth of the modulated signal, the amplitude here also increases or decreases. And I'm not sure, maybe some of you may know. So it's increasing when we when the bandwidth is narrowing, okay? And it drops when we broaden the bandwidth. So why it is happening? So that's because the integral of this signal has to stay the same, okay? So when it gets wider, broaden, then the amplitude decreases. Okay. Okay, maybe let's look at the spectrum of the demodulated signal. Wow, what happened here? Okay. So let's connect the output of the modulator to the demodulator input. And now we're going to observe the demodulated signal, but in the frequency domain. I'm not really sure why the baseline goes up here, but So this is our, so let's set the input parameters here. So let's set 2 volts and 3.4 kilohertz. Okay, and this is our demodulated signal in the frequency domain. And now we can also connect the demodulator to the low pass filter as previously. And we're going to look at the low pass filter output. Okay, so we're going to connect it here. Yeah. And this is the spectrum from the low pass filter. So now we can see that the low pass filter is for cutting, getting rid of the carrier signal. So again, this is the demodulator, just to compare these two. And this is the low pass filter. Okay. So for now, it's more or less all what I wanted to show you. So if I'm not sure why the oscilloscope. So no, the oscilloscope is, yeah, it's not running until because we can run either the oscilloscope, either the spectrum analyzer. So when we press run to any of these two, the other one stops. Okay. So if you have any questions, you can ask me now or later. If not, thank you for today. And we have the recording from this meeting, so I'm going to upload it to you to the ePortal. Okay, I'm going to